Hello, hello. Today I have the puzzle Split Decision by James Sinclair. James is just one of the top arrow and killer setters out there. You should definitely, if you're interested in that kind of puzzle, subscribe to his Substack, which I think is called Artisanal Sudoku. And he puts out puzzles fairly frequently. I saw this one on Logic Masters Germany and wanted to try it, so I figured I would record it and put it on the channel. So rules are fairly standard. If you're watching my channel, you probably know these rules, but normal Sudoku rules apply. So that's the digits 1 to 9 in every row, every column, and every marked 3x3 box. They can't repeat. You need one of each. We have killer cages. So digits in cages must sum to the value in the top left corner of the cage. And then we have arrows. So digits in a circle add up to the digits on the attached arrow. And for double arrows, I guess double is a different thing. For arrows with two different arrows attached to the same circle, those arrows are treated separately. So let's say this were 9. This might be, say, 3 and 6. And this might be, say, 4, 1, and 4. Something like that. So that would be a valid way to fill in this arrow here. And that's it. So let's see what we can see here. So immediately I'm drawn to these 29 cages, which are in 3 different places. And in all 3 cases, I have 2 arrows going into it. So the whole box is filled up. And now if I add up all the digits 1 to 9, that's going to add up to 45, which means if I take away 29, these digits are going to add up to 16. And what that means is that the circles in the separated that are off of those arrows will also add up to 16, which means they're either 2 8s or they're 7 and 9. So either way, these digits are 7, 8, or 9. And if it's 7, 9, these two, for example, are different, which means this, so I don't know how to say this. If these are a 7, 9 pair, then 7 and 9 will both see this digit. This will have to be 8. Whereas if these are 8s, this obviously won't be 8, and then so this will be a 7, 9 pair. So we have this kind of tension here where these two are either all 4 are going to be 8s, or they're going to be 2 different 7, 9 pairs. And then these two are either going to be 8s or a 7, 9 pair. Oh, actually, that's in either way, that's 8. Look at that. Oh, wait, no, is that true? No, maybe I can put 8 here. No, that's not true. I was thinking ahead and thinking that 8 had to go on this, but I actually don't know that's true. So let's slow down. So I've got, so one of these is an 8, and one of these is an 8. So if these are a 7, 9 pair, this can't be 7 or 9, that would be 8, and these would not add up to 16. No, so that's not the way I think about it. If this were a 7, 9 pair, and this is also a 7, 9 pair, these have to be the same digit. So if this is 7 or 9, this is 8, and vice versa. Actually, no, so these can't be 8s. There we go. These can't be 8s because if they are, where would it go in the box? Right? I would have 8 can't go. If these are 8s, then by Sudoku, 8 couldn't go in the 29 cage. And because of the arrows logic, they can't go here because what would I put with 8 to add up to 8? It doesn't work. So those are not 8s. So that's a 7, 9 pair, which means that's an 8, and that's an 8, and this is a 7, 9 pair. Okay, and now that's an 8 by this arrow logic, and plus Sudoku. And now, 9 has to go in these 29 cages, but not because you need 9 to get to 29. It's because 9 can't go on the arrow tips. So 9 is definitely in these cages. Actually, let's think about this one first because I see the sums in here. So this cage is going to be 9, 4, because I can't put 4 in an arrow. And then 2 digits is summed to 8 because 9, 4, and 8 is 21. That'll leave another 8. Or another way you can think about it, that is there are 3 different ways to sum to 8. One of them goes here, one of them goes here, and one of them goes in this 29 cage with 4, 9, and 8. Which is just something to keep in the back of our minds as we think, because I don't think I can do anything directly with that. Okay. I was going to say these have to be different, but that's not quite true. These can't both be 9. Because if they're both 9, where would I put 9 in box 5? I can't go on an arrow tip. And it couldn't go here by sudoku. So these could both be 7, though. I could put 7, 1 here, say. So these don't have to be different. Okay. Let's think about, so now 29 has to be in this cage, but it also has to be one of these. So I think these arrows can't be 9 because like 9 has to go in here somewhere. So either 9 is here, in which case 9 can't go in this, or 9 is here, in which case in the 29 cage it goes in one of these 2 spots, and then it still can't go here. So another way to think about that is 9 has to be in one of those 3 cells. So it can't be here. By the same logic, 9 has to be one of those 3 cells, so it can't go here. Which means this cell, it could just be so low is the problem. From a 21 cage perspective, it has to be at least 4, which is not so big. Am I really going to mark that like this? I mean, this could be 3 to 8. And 4 would work. 1, 1, 2 works here as well. Well, I can do a little bit. This can't be 5 because that would imply a 7, 9 pair here, which would break this. In fact, no, I can't put 9 here at all, right? Because of this. So this can't be 4 because I would need 9, 8, which doesn't work. 6 could take 7, 8. That's fine. 7 can take 6, 8 only. 8 can take 6, 7 only. So this is a 6, 7, 8 triple. Is that right? So 9 doesn't go. Oh yeah, 9 doesn't go in this. 9 doesn't go in this cage now, and it's 21. Maximally is 8, 7, 6, which is what this is. Can I do the same thing here? 9's not in this cage by the same logic. 9 doesn't go in here, so this has to be 8, 7, 5. Okay, that's good. I want to do the 7 logic here like I do with 9s, but this could be 9, 7, 2 or something. So that doesn't work. 7 does not have to go in this cage. So what is it? So I'm just trying to, so I'm wondering if this is 7, does that cause a problem like because of this 6, 7, 8 triple? So if that's 7, this is 7, and this is 7, but that's okay. You get a 7 in there, and here, and these are 9. Oh, that's a long way around to break. So this, let me see if there's an easier way to think about that. This can't be 7, but that's a long chain of logic. So if this is 7, which means that's 9. Which means this is 7, and this is 7, which means that's 9. I get 2 9s here, which we said can't happen. I bet there's a more elegant way to see that. What happens if one of these is 7? So I know that this is 9 to avoid this. If this is 9, the other one has to be 7. But can I do something where if this is 7, the other one also has to be 7? So if this is 7, what happens? Yeah, I get that. I wonder if that's what it's supposed to be. Maybe that is just what it's supposed to be. I'm just going to take a second to look for something a little shorter. this is 7, we get 9, 9. Because 7, 7, 9. Yeah, that's pretty short. I think that's okay. Yeah, I think that's okay. I'm going to use it. That's 7, that's 7. Those are 9, which means those aren't 7, are not 7. So that's 7. Now 7 actually doesn't go in this cage, and it can't go on its own arrow, so that's a 2, 7 pair. And then same thing here, that's not 7. I even made the same mistake of corner marking instead pairs. Yeah, it's so symmetric. It's and that's so beautiful. I wonder if this, I bet there's an easier way to see that, but I'm not seeing it. 9's in here somewhere. So we're going to break symmetry at some point. I wonder if this is going to be a 9-4 pair. I bet it is. 2's not in here now, so this is 1, 3, 4, 6. Same here. I wonder if these can only be 6 or 5. But I don't see a reason that they can't be. 7 is in one of these, which means 1 is in one of these. 9 is here, I guess, and here. I can do some, no, 9, yeah, 9's there and there, and here and here. Okay, not so great. So what's the next step here? 8 has to go in this cage now, and 8's in all of the cages. So there's going to be 9, 8, which is 17, and then 3 to just which add to 12. I wonder if there's going to be 1, 7, and 2, 6. There's going to be 2, 7, and 1, 6, and these are all going to be the same. Would that be 3, 4, 5, 8, 9? That might, I don't know how to show that. Can this really be 5? What happens if this is 5? If this is 5, oh, hold on, no. Yeah, this is good. 8 can't go in here, so 8's there. Which means that's 5 and that's 8. I can probably do the same thing here. Yeah. One of these is 8, which makes this 6 and that 8. Yeah, that's much better. That's much nicer. But it does mean these arrows are pretty flexible. Except this one actually, I know is the 3, 5 pair. This one's a 2, 6 pair. So this is not 1, 6 or 2, 5. This is 3, 4. So, and that's not going to work up here. So these are not all the same. And here I have 1, 6 is in here. So it's actually a 9, 6 pair. And this becomes 1, 8 and 1, 8 and 5. Oh, this is just a 1 then. 5, 8 pair. These digits, oh, there's no 1 on this now. So this is no more than 3. What are these? 2, 3, 4. That's not 2. Because of this 2, 7 pair. This could still be 3, 2, 3. That's pretty small. One of these is definitely a 2 though, so that's not. So it's either 3, 2, 3, or 1, 3, 4 pair. Oh, this get 3, 5. This is a 4. Okay, so now these sum to 4, so that's a 1, 3 pair. Whoops, not there. And then 3's not here, but 3 could still be here. Yeah, this one, I'm tempted to say that means this is a 3, 5, but it's definitely not. I mean, it's definitely not a logical deduction. See, 7 is here. 5 can't go here because that'll be a 5, 2 pair, and 2 is accounted for. So this is actually 9, 5 pairs, like this is a 9, 6 pair. It's all very, very symmetric. Very, very pretty. 8 is in one of these spots. And then same over here. This is, I guess 1, 3, or 4. Can't be 2 because of that, or this. The smallest this could be is 1, 2, making this 5. So this is 3, 4, 5 because it's not 1 or 2. So the biggest this could sum to is 5. So these are between 1 and 4. I'm getting pretty pencil marky. I'm sure there's a nicer way to see this. Oh, 2 goes here, and therefore here. I could probably do something like that here. No. What's the difference? Oh, this way. 3, is it 3 or 4? Why did the 2 work? 2 worked because I had a 3, 5 pair up here. Oh, so it's this way. Yeah, it's, wait. This 2, 7 is this 2, 7. Oh, but yeah, this was 3, 5 and this one's 2, 6. So it doesn't work here because that's 2, 6. Interesting. Okay. These 3 digits are 2, 3, and 4. This 8 sees this very obviously. And then 5 is in there. I know the other digit here should be 1. 1 could go here or it could go there. We're at 9, 8, 5. The other 2 digits add to 7. And the other one's that. So I guess I just, hold on. This isn't 2, 5. It's not 3, 4. So this is 1, 6, which means this is 8, 3, 4. Okay, so this means that's 1. Okay, now these add to 7, so that's 2, 3, or 4. 3, 4 are taken, so that's 2, that's 5. Yeah, okay. Getting on track here. 2 has to go in here. But I don't know if it's on the 8 or in the cage. Okay, so that's not as helpful. 7 goes in here with 9. No. No, 7's there. This is 3, 4, 9. The other one goes in here with 6. The other one being this 3 or 4. This is 1, 7, or 3, 5. This is 1, 7, or 2, 6. Five. No, I feel like I don't know why I feel like I should know something about that. Okay. Ones in here. This is 1, 3, 4. This 3, 4 goes in one of those spots. The other missing digit is 6, which I know goes down here with a 5. 8, 4 makes this 3. Okay, so I have that same way I have this. I should be looking more at the symmetry and seeing if I can find something one place, I can do it in the other place. Even though they're different digits, it's worked that way. So this is a naked something. 6. And then 1, 3, 4, 7, 8. Don't see it. Okay. 3, 4, 9. 3, 4, 6. 3, 4, 2. I should know these digits are 1, 9, and 5. How are we going to get to the center? I don't know. It seems pretty loose. I know this digit. Oh, this, yeah, okay. That's 1, 3. This is 2, 4, 9. I can probably do that. I probably have something like that everywhere. Maybe not. No. Yeah, because this 2 is different than this 2, because this is 3, 5, which is why this 2 got placed. I don't have that here. But this 2 gives me 7, 2, which gives me 7 here, which gives me an X-wing on 7s, putting a 7 there, which gives me 2, 7 over there. 2, 2 gives me 6, 2 here. 6 gives me 1, 6 here. 1, 1, not so helpful maybe. 3, 4. 5 gives me 9, 5, which gives me 9 there. So let's see. Yeah, this is definitely gonna be 9, 4, right? And then the other digit's 3. I get a 3, 4 pair in the column, which fixes that 3, 4. Oh, we don't get that. We get 3, 3, 8. No, yeah, 3, 9, which means 5 is actually in here with 4. And I don't know how any of those go. Not yet. And then this, now we need a 2, 6, which can't go here. So this is 2, 6. This is 7, 1, which fixes the 1 over here. We get an X-wing on 6s, which puts 6 there. 4, 5. I still don't know which way 4, 5 goes. Which I think is a little weird. Or not weird, but surprising. Where does 7 go in this row? It can only go there. Where this 7 rules out that 7. 1, 2, 3, 5, 8, 5, 6, 8. 5 has to go here. So this is now a 6, 8 pair, which gives me a 6, 9, which gives me the 1, 9. I guess I had a 1. How long have I had that 1? Yeah, there's a lot of sudoku that I'm just missing here. I probably know this digit. I don't know this digit. Yeah, I don't know this digit yet. These are 3, 4, 8. 6, 8 sees that 2, 6 pair. 4, 5 must see something. No, the 3 sees 4, 5. 4, 8, 6. All right, we're getting there. We're getting there. This is 6 or 3. This is either of them, I think. I don't see anything restricting that. This is 2, 3, 4. I mean, there must be something. I'm not seeing it. Okay, 5. This 5 sees here. 9, 5. 3s. What am I missing? I'm just gonna go through it because I don't see it. Oh, there we go. 3, 4. It's 3 down here, which gives me these. 3 also gives me those. 2 gives me these. And then 4, 9, 2. Whew, okay, we did it. All right, very nice puzzle. I'm gonna go back and see. I probably won't edit into the video, but I'm gonna go back and see if I can find something with this 7, 9. I feel like there might have been a more elegant way that I just bulldozed through. But very, very nice puzzle. And so thanks for watching. We'll see you next time. Bye.